Welcome back, everybody. Today we're going to wrap up our first chapter on basic Java. And throughout this chapter, we've been working our way towards building real computer programs. Now, what do I mean by real computer program? Well, all computer programs essentially do four things. Okay, they take input from a user, they store that information somewhere, they process the information, and then they give output. Now, as far as what we can do so far, we can take input. That's what our scanner is for. That's how we've been doing it so far. We can store the information. That's in the form of variables. What we're going to really look at today is processing that information, okay, using some different math operations. And then we have the output. We've been doing that since day one. That's our system.out.print, printing to the console. Okay, so today with those math operations, we'll say we're writing real computer programs here. Now, we've already had a little bit of math mixed in with our program so far, but it's been pretty basic. Okay, today we're going more in-depth, obviously. So let's start by breaking things down. Let's talk about Java expressions. Okay, an expression is just something that consists of operators, variables, and or literal values. So for example, here I have a line of code which is a Java expression. Okay, average and total are the variables in this expression. Okay, when I say operator, we're talking about something like add, subtract, multiply, divide. So the division sign is the operator here. And then 5 is the literal. Anytime we put an actual value into that expression, we'll call that a literal part of the expression. Now, as far as operators go, we're talking about your basic addition, subtraction, multiplication, and division operators here. And then the new one that you really don't see much in math class but shows up a whole bunch when we're talking programming is this modulus operator, mod. It has nothing to do with percentages, but that's the key we'll use to get it in there. We will spend a good chunk of time talking about mod or modulus as we go through this lesson today. Now, for the most part, our math operators work the exact same way they have in math class for years. So what I have here are 4 lines of code. Each of them is going to print out kind of the string for the expression of the calculation I'm doing. So we'll concatenate the actual value to our expression. So when I go through here, we have a 6 plus 5 gives us an 11. 6 minus 5 gives us a 1. 6 times 5 is going to give us a 30. And then 6 divided by 5, that doesn't seem quite right. We get a 1. Now, if I pull out my calculator and run that out, I end up with a 1.2, so I end up with a decimal. Now, what's happening here is we're doing integer division. These are all integer operations. And basically in Java, anytime you do operations with containing only integers, you're going to get an integer value when it's all said and done. Okay, so when I do 6 divided by 5 on my calculator, I get a 1.2. What Java's doing then is it's not rounding, but it's truncating that decimal portion of it. It just throws it away and leaves me with a 1 for an answer. Okay, in some case, that's exactly what we're looking for. Okay, as far as integer division, we'll see some examples of that in the next few coding exercises. In other cases, what we'll have to do is utilize doubles then, okay, to get the decimals we're looking for. Now, for doubles in Java, our operators are going to work the exact same way we're used to them working in math class. So once again, I have 4 lines of code here. And notice I have some doubles and ints mixed together. So the first line, we have the double 1.6 plus the int 5. And when I add those together, I end up with a 11.1 like I'd expect. And notice Java gave me that answer as a double rather than an int. Okay, same thing if I do the int 6 minus the double 5.2. That's going to give me a 0.8. Okay, in Java, as long as one of the values I'm dealing with is a double, it's going to turn the entire thing into a double operation and give you that double value. Same idea for a double 6.1 times the double 5.2. Double times double will be a double. It'll give me that value. And then here we have double division, 6.1 divided by 5.2. Okay, if I do that on my calculator, I get the exact same thing. Okay, so with the double operations, I get the decimal places there. They don't get truncated, they don't get cut off. So again, just to reiterate there, if I do division or any type of operation with all ints, such as 1 divided by 2 using Java math, that's going to give me a 0. Okay, it's going to truncate that decimal place. 1 divided by 2 with our real numbers would be a 0.5. Okay, we're not rounding. 0.5 rounds up to 1. We're truncating. We're just cutting off those decimal values. Okay, so if the operation involves all ints, we're going to get an int value out. Okay, now if I do the exact same thing, 1.0 divided by 2.0, okay, double division, I will get those doubles. I will get that 0.5. And then in the last two examples, when we mix our ints and doubles, 1 divided by 2.0, we'll get that same 0.5. 1.0, the double, divided by the int 2, we'll get the same 0.5. So what we're showing here is as long as one value in that expression is a decimal, is a double value, we'll get a double answer out. If everything's an int, we'll get an int value when it's all said and done. Now, a couple special cases of division, okay, dividing by 0 and dividing 0. Okay, the first one, we said math for years, don't divide by 0. Okay, 1 divided by 0 causes a runtime exception to be thrown, okay, a runtime error, as in as your program's running, it's going to crash. All right, and then also in Java, we can't divide 0 by something. Dividing by 0 results in a value that is not a number. We'll abbreviate that as NaN. So not a number that is a thing in Java. Okay, something we can check for, but if I try to use NaN in terms of expression, trying to add that or subtract that or use any other type of operation on it, my program will break for me. Okay, so in Java, whether we're talking ints like we have here or doubles, you can't divide by 0 and you also can't divide 0. We'll say that's not a number as well. All right, now the big new operator for today is going to be the modulus operator, or we'll abbreviate as just mod. Okay, this is something that we don't typically use in math class. We really should use it a lot more though, because we're going to see as we go through the year a lot of different situations where we want to use this mod operator in our programs, including right away for the coding exercises for this lesson here. Okay, so mod, which we'll type in as the percentage sign, again, nothing to do with percent, it gives the integer remainder of integer division. Okay, so for example, if I take 8 and divide by 3, 8 isn't divisible by 3, there's a remainder. Okay, thinking back to like elementary school math, we know that 3 goes into 8 2 times with a remainder of 2. So the output of this first expression here would be just a 2. Okay, again, that's the remainder after integer division. Okay, so that's kind of the basic case, and I've got a few special cases for you here. If I flip those numbers around, this is something to just kind of memorize. If I go 3 divided by 8, well, 8 doesn't go into 3. Okay, we could say that 3 is equal to 0 times 8 plus 3, 3 for a remainder. All right, so anytime you do modulus, smaller number, mod, larger number, it's just that first smaller number that'll be your remainder. Again, because we can think of 3 as equal to 0 times 8 plus 3, 3 is that remainder. Now, if we have two numbers that are divisible by each other, so 9 mod 3, in other words, what's the remainder when I take 9 divided by 3? That's going to be a remainder of just 0. And as we move forward, that'll be something we check on a lot to see if it is divisible by. Do we get modulus for a remainder? And then the last case, we usually won't worry about mod with doubles, but if I go 9.2 mod 3, what do I end up with? Well, it's that remainder, it's that 0.2. Okay, that's kind of the leftover after I do division. Okay, so again, we'll see a lot of practical applications where we want to use this modulus. We'll say mod gives the integer remainder of integer division. Now, one of the big ways we'll utilize this modulus operator is to take numbers and pull them apart to get their individual digits. So we'll say mod 10 and division can be used to extract individual digits from a number. So let's say I have the variable num assigned with a 45. Okay, well, what are these two lines of code going to do? If I print out num mod 10, that's going to give me the remainder after division by 10. So in other words, it's going to give me the last digit, the 5 here. And then I can utilize integer division to get the other digit. Okay, num, the 45 divided by 10. Okay, that's going to give me a 4.5. But since we're talking integer division, Java is going to truncate the 0.5 and leave me with just the 4. Okay, so that's the basic idea, using mod 10 and then division by 10, 100, 1000 to actually extract the digits. Again, that'll be something that shows up in a lot of different type of applications for us as we're writing programs. So next thing we're going to talk about is precedence in Java expression. In other words, the same thing as order of operations when we're talking math expressions. And for the most part, it works the same way it does in math class, except for in Java expressions, we have a few additions. We have the increment operators and then some compound assignment operators, which we'll talk about in a few minutes. But for the most part, things work the same way they do as math class. I'll start off with what's inside my parentheses. Okay, typically I won't mix in the incrementer and decrementers with my expression, so we don't really need to worry about that. So it's parentheses, then it's multiplication, division, and mod, which is essentially doing division, okay, from left to right, just like in math class. Then we'll do our addition, subtraction. And then finally, after that, we'll use the assignment operators. Okay, so essentially, we use these to assign variables. And with them coming late in the precedence, Java is going to take care of any of these other operators before it assigns anything. We're not going to worry about the comma. I can't even think of what that's for at this off the top of my head here. But so there's our precedence. Again, essentially works the same way as order of operations in math class. We'll do a few examples where we kind of highlight that here. So taking a look at some examples of code, I've got an int variable called num that will assign right off the bat with 10. And let's say I print that right away. That's going to print off just the 10. Again, I can use operators to reassign that value. When I run the code num gets num plus 5, what that's going to do is it's going to take the previous value of num, which is a 10, and add a 5 to that. And since our assignment operators are low in precedence, it's going to do this addition first before it reassigns, meaning that when I print num again after that line of code's run, we'll get the 15 there. Okay, mixing stuff together here. Like we said, when we have an expression, the mod, okay, along with multiplication division, is going to happen before addition subtraction. So here when I reassign num to 10 mod 3, well, what's the remainder when I divide 10 by 3? It's a 1. Okay, 3 goes into 10 3 times, the remainder of 1. So this would be a 1 plus 7. Num therefore gets reassigned to an 8. When I print it, we get the 8 there. Next thing we're going to talk about are the compound assignment statements. Let's explain what those are here. So again, I've got an int num, and this time let's assign it to 11 right off the bat. And with this next line of code, what it's going to do is it's going to add 3 to the num and reassign it all in one step. Okay, a very common kind of step we'll take in our programs is to take a variable and add something to it. So this line of code here is equivalent to num gets num plus 3. Okay, so when I print this, what it's going to do is it's going to add the 3 to the 11. That's just, which gives me a 14. That's just kind of a compact way to add something to it and reassign in one step without rewriting the variable again. Again, since that gets used so often, it'll be something we do a lot. Okay, there's a shortcut for it. The mod compound assignment statement works the same way. So this is going to reassign num to whatever the current num mod 3 is. Okay, let's see here. 3 goes into 14 4 times with a remainder of 2. So when I print that, I should get a 2 out. And then the multiplication, division, subtraction works the same. This statement says to take num and reassign it to num times 5. Well, 2 times 5 is 10, so I should get the 10 when it's all said and done there. Now, doesn't matter which way we write things, if we rewrite it as num gets num times 5, okay, or use the compound operators, both work the same way. Again, this is just a little quicker, a little more efficient to type in. Now, just like taking a variable and adding something to it and reassigning it will be very common. Okay, adding 1 or subtracting 1, kind of counting up or down on variables will be common as well. That's why we have the incrementing and I suppose decrementing operators. And what those are is, let's say we have int num gets 11. When I print that, we've got an 11. If I run this line of code num++, what that does is it reassigns num to just one more, as in 12. Okay, num minus minus is just going to count that variable num down by 1. Num++ would count it up by 12 again. So this num++ is essentially the same as num plus equals 1, okay, which means the same thing as num gets num plus 1. Okay, again, since we're counting up by 1 or counting down by 1 so often, we have these additional shortcuts for incrementing and decrementing. Now, the last thing we're going to talk about today for Java operations is something called casting. Now, casting is used to temporarily change the type of a value. So here's an example of casting. Let's say I have an int, a value of 5, and then I want to store that int as a double value. Okay, it would not be legal to say double my double gets my int. Okay, this is trying to store an int value as a double. I can't do that. But what I could do is I could cast my int as a double. Can you do that in Java by putting the type you want to cast it as in parentheses ahead of the value? And what that would do is that would turn the 5 into a 0.5 and allow me to store it as a double. Okay, so it doesn't permanently change my int, but it temporarily changes its value to a double, so therefore I can use it as a double, treat it as a double, and apply it in Java as a double. Now, why would I want to do something like that? Why would I want to utilize casting? Well, a pretty typical example is doing division and taking averages in Java. So let's say I have two ints, we're assigning two ints, num1 to 5 and num2 equals 2. And I want to do some division with them, like for example, like we said, find an average. Now if I just straight out divide them with integer division, we know we're going to get an integer solution. Okay, so in Java, the int 5 divided by the int 2 is not 2.5, it's just a 2, okay, truncating the decimal. What I can do though to get that 2.5 out is I can cast either one of these two values as a double. So if I temporarily change num1, the 5, into a 5.0 by casting it, we then have double division, and we'll get that 2.5 out. Like we said earlier, anytime you have a double mixed into a Java expression, the result will be a double. Now I can do the same thing by casting the second number. Okay, so 5 divided by 2.0 will give me the 2.5 as well. Now in the last example, this is something that actually won't work as intended. Okay, if I cast the whole expression as a double, we get a 2.0. Now why is that? We said as far as precedence goes, Java is going to do what's inside parentheses first. So it's going to do this int division, okay, which would go 5 divided by 2, integer division would be a 2, and then cast the result as a double, so it would cast that 2 to a 2.0. Okay, and this will be one of the tricks as we're working through more complicated expressions, making sure we cast at the right time. Okay, this last line of code is an example that's not going to give us quite what we're looking for. All right, so there you go. There's math in Java. Now the trick is sometimes it works the way we're used to in math class, other times it doesn't. Okay, so it's kind of a pain to start learning, but as we're going through the semester, as we're going through the year, you will see why Okay, math with integers is nice in some points, and math in doubles is nice, and it's good to be able to switch between them. Okay, so there is an intent behind why Java works the way it does, and you'll see that as you go through the course here. Okay, so for now, just kind of take my word for it, memorize those rules, memorize kind of when to use different types of math, start working on some programs, start cranking out some code, and like always, if you're getting stuck, we'll be here to help you out. We'll see you folks next time for Chapter 2.